Hello, and welcome back to Dave's American Flyer Trains. This video, and any that might follow it in the series, is going to focus on a very specific replacement of critical parts in the 470 Alco diesel. Now we know the 470 that you see in the background, the Santa Fe. This one came from set 4713, the ABA unit, produced by Gilbert 1953 to 1957. It is the Chief Type 2, which distinguishes it as a Type 2. You can see the Chief on the cross on the hood, the front of the hood. And the other thing that distinguishes the Type 2 are these double pins holding on the sheet metal steps. First, before we talk about the remedy, let's talk about the symptoms. I was able for many years to operate this train, its ABA unit, in 4 passenger coaches at a steady state, a regular steady state, by placing the indicator on an 18B transformer on the 0 in 60 miles an hour. What I got out of that was very steady state operation, and I got out of it approximately 70 miles per hour scaled speed. Well, first of all, let's talk about how was it that I knew that it was approximately 70 miles an hour in a scale speed. Well, I used from modelbuildings.org, a train scale speed indicator. And on that indicator, I use S-gauge. I choose the 60 inches of straight track that gives you the inches per second, miles per hour, or the kilometers per hour. It's a really interesting tool, and it adds a little science to the project by getting a scaled speed. But what I noticed over, and continuing with the symptoms, what I noticed over time, over maybe 18 months, 2 things. It didn't operate as well, meaning that it was dropping in speed when it was set on the same indicator on the transformer, and it was producing significant heat, it being the motor unit, this one with its dual motors. The heat was very excessive. The first thing that made me notice it was kind of a burning oil grease type smell that was coming from the locomotive. The next thing I noticed was the excessive heat on the bottom of these motors. It was, you couldn't touch it. It was that hot. It was painfully hot. And you wouldn't even want to put your skin on there but for a few minutes. And I consulted with some of my colleagues, specifically some experts in the area, that said that probably what you have somewhere, and I did rebuild both motors, and I told them that I said I cannot find anything within these motors that I think could be producing that kind of heat, not even the brushes. Well, their response is that it's probably heat or a friction that is a drag that produces resistance that opposes motion. And they said that most likely is the oblong bushings in the trucks, that they're just getting too far worn and they are producing a lot of heat. And it can produce damage elsewhere. I mean, after all, think about it. It pushes, that phenomenon pushes the drive gear up tighter against the worm gear on the armature, which is not good. And then you get all kinds of heat problems. And they said that's probably where your heat is coming from. And since you lubricated it so well and so good, that it's actually burning off some of that lubrication. It gets so hot. So they said the recommendation from several experts was to leverage the science, and the science of using the scale speed indicator that says that performance is definitely degrading and that temperature is increasing. And I used a surface thermometer, a laser surface thermometer, to measure the heat on those trucks, and they were in the high 140s, I believe, at one point. So I had to do something about that.